fuselage holds the structure together and accommodate passengers and/or cargo. Modern aircraft fuselage may accommodate up to 800 passengers in economy class and up to 112,700 kilograms cargo. The cockpit holds the command and control section of an airplane. Modern aircraft cockpits have a number of vital instruments for controlling the airplane on the ground as well as when flying. Engines generate thrust and provide hydraulic and electric power. Modern aircraft are employed with different types of engines, although jet engines are favored by most commercial airliners. The undercarriage, also known as landing gear, provides a platform for the aircraft to stand as well as plays an important obvious role in landing and takeoff. Wings generate lift and control the airflow while flying. Wing design is a crucial factor in aviation. A wing is designed to reduce drag at the leading edge, generate lift by its crescent and manage airflow using the rear edge. Furthermore, while gliding without engine power, the wings allow the pilot to increase and decrease the descent rate. Slats adjust the angle of attack of the wings, increasing lift. Slats are fitted at the leading edges of the wings, and deploying them increases the angle of attack of the wings, allowing the pilot to increase the lift generated by the wing. Flaps adjust the camber of the wings, increasing lift. Flaps are normally fitted at the trailing edge of the wings. Extending the flaps increase the camber of the wing's airfoil, thus increasing lift at lower speeds, an important feature for landing. Spoilers adjust the camber of sections of the wings, decreasing lift. Spoilers are fitted on top of the wings, and are used to reduce lift on a section of the wing in a controlled manner. Spoilers are useful for decreasing lift without increasing the airspeed of the airplane or without increasing drag significantly. Ailerons increase or decrease lift asymmetrically, in order to change roll and, thus, move the aircraft left or right while flying. Ailerons are hinged sections fitted at the rear of each wing. Ailerons work asymmetrically as a pair. As the right aileron goes up, the left one comes down and vice versa, thus making the aircraft roll right or left, respectively. The horizontal stabilizer helps maintain an airplane's equilibrium and stability in flight. It does so by providing a mini-wing at a certain distance from the main wings, typically at the back, although it can also be positioned at the front of the aircraft. This smaller wing produces enough lift to control the pitch of the aircraft and maintain its stability. Although an aircraft without a horizontal stabilizer could, in principle, fly with wings only, controlling its pitch and airspeed would be difficult, as pitch and, subsequently, airspeed can be easily disturbed by air conditions. As soon as the aircraft pitches up, the tendency is to continue pitching up even further and decrease airspeed, and as soon as the aircraft pitches down, the tendency then is to continue pitching down even further and increase airspeed. An aircraft with a horizontal stabilizer, however, could be flown handoffs, once correctly trimmed, without affecting its pitch and speed. Elevators increase or decrease lift on the horizontal stabilizer symmetrically in order to control the pitch motion of an airplane. Elevators are hinged surfaces fitted at the rear of the horizontal stabilizer. They work symmetrically as a pair. When the elevators are up, the aircraft ascends. When the elevators are down, the aircraft descends, and when the elevators are horizontal, the aircraft flies straight. The vertical stabilizer prevents lateral movements of the airplane. Without a vertical stabilizer, most aircraft would lose lateral control, tend to slip, increase drag, and become uncontrollable. The rudder controls the yaw motion of an airplane. The rudder is a hinged surface fitted to the vertical stabilizer. When the rudder is turned to the left, the aircraft turns to the left in the horizontal plane. When the rudder is turned to the right, the aircraft turns to the right. The rudder is used to turn the aircraft left or right on the ground. In the air, however, the rudder is primarily used to coordinate left and right turns. The turns themselves are done with the ailerons, or to counter adverse yaw, example, when crosswinds pushes the airplane sideways.